Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
I'd like to have Tony Hay come up and share a few words with us and get us underway.
Thank you very much, Harold. Yes, so this year, as you see, we revealed the identity of the Jim Gray Award winner last night, and we thought it would be a very good idea to give the Jim Gray Award winner an opportunity to give a keynote. So that's what we have arranged this year. And I've talked to Phil. His vision for open access data and publishing is a very interesting one, and it fits very well with Adam Bly's presentation last night. And so I sung all Phil's praises yesterday, so I don't really think I need to do more except ask him to explain the title. But Phil, The Reaming of Life.
Thanks, Tony. Well, I'm totally devastated that Carol just pointed out me a completely different meaning of reaming that I wasn't even actually familiar with, which is, so I'm absolutely so embarrassed already, I can hardly start. But I'll hopefully be able to recover by telling you kind of what I meant by it. But I always start by making a disclaimer. I should probably add a bullet to this after this, that my knowledge of the English language is sadly lacking. So I'm coming, what I'm going to tell you is really from the point of view of a domain scientist, and I'm going to use that as examples. And I think the reason I'm kind of in this business is I'm just lucky enough to be in a situation where I have access to very large amounts of data, and working with the literature and open access literature through my role with the Public Library of Science, which allows me to do an experiment with some interesting things. And I'm really part of this whole long tail. I'm not someone who generates myself an enormous amount of data. I'm speaking, frankly, for the majority. And I think, in some ways, the majority, and I'll make these points, are underrepresented in all of this. And I admit I'm naive, so feel free to yell out and contradict me if I say something wrong, or at least in your mind. So let me now try and explain what I meant by the reaming of life. So God, it's going to be very hard now. So a reamer is a tool for turning a rough punched hole into an accurate and smooth one. So if I think about the data deluge as that sort of rough hole, and I think what we're trying to do here is essentially to smooth the path between that data and really ultimately the comprehension. And so, I think you can say it's being analyzed, visualized, distributed, but it's really the comprehension, ultimately, that's really the important thing. And that's where I think we're sadly lacking. And so what I'm going to do is actually, I think Adam gave, as Tony's already alluded to, I think what I'm going to say actually does sort of follow on, in the sense that I think Adam painted a beautiful and broad picture, and I'm actually just going to give you a few little examples of probably a subset of the 5 pillars that he presented last night. I'm going to do this, this is actually supposed to be a play on the meaning of life, and if you remember the meaning of life, this is a scene where John Cleese is actually, there's a couple having dinner and they don't know what to say to each other, and he's giving them conversation cards. So that's a conversation card about Greek philosophers. Well, what I'm trying to do here is to add to what has already been said, and to actually just sort of increase the volume of conversation around these things by virtue of hopefully some interesting ideas. The issue, I think, most of all, is we absolutely need to accelerate the process of discovery and comprehension. And I'm going to give you, and I think this is what Jim was saying all along in the fourth paradigm and other places, and I'm going to give you a couple of examples why I think it's absolutely paramount. So the scientific process in general is just too slow to respond to a crisis. What we do, either global or personal, I'm going to give you a couple of examples of that. what we've done for essentially ever since the beginning of science, when it was very empirical perhaps, is we've pushed. We are all pushers. And basically so here's science, here's a society, and that we push onto them and they accept what we give them. But there are times when they actually want to pull. And those times are usually times of some kind of global or personal crisis. And I actually think we're likely to come up very short in this process, particularly given the current kind of process that we've developed over the years, where it could take months to publish a paper. We could all be dead. It's an exaggeration, but we could all be dead by the time that happens. But we respond to these sorts of events. So here's just an example from PLOS. This is PLOS currents. And basically it was set up during the time of H1N1 to really enable the getting information out there very quickly. And so it was actually done under a copyright arrangement so people could then go and publish that information later. But it enabled things essentially to be published overnight. There was some level of moderation. I mean, there are many permutations on this model, okay, in terms of hubs and all these kinds of things. But this was a place where you could go. There was some level of editorial oversight, but things went out there very quickly. So I think that's an example of the type of response. But this is a one-off. Okay, we need this on a regular basis. We need much more of this constantly. So we need this fast access. And so here's an example of this relative to the data. Okay, so what I have over here on the right is just essentially. Oops, sorry. Oh dear. All right, press the right buttons. All right, well, I'll use the mouse. But essentially, the growth in the number of cases of H1N1. And what you have down here is actually this is from one of the databases that I'm involved with. This is the Protein Data Bank. I'm just going to use these as illustrative examples. The actual science per se is not that important. But it's basically the three-dimensional structures of all biological macromolecules. I know many of you are familiar with it. And what we saw is essentially access to the data. These two graphs at the bottom here from Google Analytics are basically around two structures which are actually the receptors on the viral coat protein. And so what happened is that there was basically flat, and suddenly when the epidemic broke out, the data was there and was accessed heavily. And then, of course, it dropped off again as things dropped down. So these are just illustrative examples of the fact that, in this case, the data was there. Did we really do the best possible job in allowing the scientific community and actually the public at large to understand the implications of this through this data? I mean, at least it was available, but in hindsight, I think we could probably have done a better job. And this is one of the cornerstones of molecular biology. It's a well-funded resource. Did we do the best possible job? I doubt that. So if that's not enough, let me give you a little more motivation. Okay, so and this comes not globally but from people, and it comes from those of you who are at the SAGE Bionetworks meeting. There's a couple who will be familiar with this story, and it's one of the two times I've been in a scientific forum when I've been absolutely, totally moved by what someone had to say. I know that's not going to happen today, but this is Josh Summers, a remarkable young man, and essentially he was diagnosed with a disease called Chordoma, and it's essentially a rare form of brain cancer. He was actually a freshman at Duke in engineering when he was diagnosed with this disease. And he got up and told this story at the Sage Commons meeting in a total, just ordinary way. There was no emotion or anything about it. And that, I think, in some sense made it so moving. So there are no known drugs against this disease. You can have fairly major surgery followed by intense radiation. So basically, this is the sort of outcome. Typically, if you last 7 years, you're lucky. And the cure rate is pretty low. And he was already 2 or 3 years into this when he was telling us this story. Okay? But what he did was he didn't just despair. Ironically, and perhaps fortuitously, the only NIH-funded investigator to work on this disease was also at Duke University. So he basically gave up engineering and went and joined his lab as a volunteer. And what he found was, well, first of all, they formed the Chordoma Foundation and with his mother, and they had, as you can see here, 2 meetings. They brought experts from all over the place to actually start exploring this disease, to accelerate the process. So this is what this talk's all about, accelerating the process to comprehension. And I think what he first realized, of course, is that the process itself to actually get to the point of a new drug is very slow. It's not a matter of, it's all about standing on the shoulder of giants, sure. But, from his point of view, by the time he's going to climb up there, it's too late for him. And so, 15 years and whatever it costs to get a new drug into the marketplace, and there's a lot more than just the research aspect to this, obviously, but notwithstanding, he doesn't have that kind of time. And what he encountered in all this was this kind of model. Essentially, that each lab, there might be a fair degree of communication within a lab about the piece of research that's needed to address this problem. But the communication between the labs is long and slow. And the whole process takes a long time, particularly when publication gets into the mix. And so what he was pushing for, and what he believes the power of the commons in general, and in this case Sage Bionetworks and all the work of Science Commons and so forth, is really to compress this whole thing. And that's what this lecture really is about, is compressing the whole thing to the point of greater comprehension. And, to make it, these are people who are involved in that process. The ones that have circles are the ones that have already passed away, who are patients or have this disease. So from their point of view, they can't wait 6 months for a paper to be published, by which time, it's going to be too late for others. And, I just had to pass on this information because it's so compelling. And I encourage you, I posted these slides on SlideShare. I know you can't read this, but, and you can go and listen to his talk for yourself. It's very moving. So hopefully that's a bit of motivation. So let's try and break down what we need to do to respond to that motivation. And so here's a sort of few big, there's lots of things, but these are just a few things that I came up with in my head to accelerate the rate of discovery. It's all about access and communication and so forth. So I'm going to go through each of these, not all of them, some of them, so the need for openness was covered very well last night. But this slide will keep coming back, and we'll go through each of these points. So I won't go through them all right now. And I've tried to sort of describe, at least from my sort of point of view, how easy and hard each of them might be. So I'd say the first thing, to me, is such a no-brainer, and yet it doesn't exist in really any significant form, is we need the data and the knowledge about that data to interoperate. We need new, fast kinds of interoperable publications where the data and the knowledge about that data are intermingled. So here's an example from my own, and I'm sorry a couple of you saw this last week, but I've always used this to illustrate the sort of craziness I'm talking about. It doesn't matter that it's from my field. I think it's as a practicing scientist, this is what I feel I should be able to do right now. And I can't, in many ways, understand why I can't do it. So basically, I start off with a view of some content. Just for this, it could actually be a database view. Here, it's a journal page, what was a traditional journal page view. That's only one view I should have on that knowledge and data. But that's where I start. I mean, right now, what do you have? You have a set of thumbnails in that, and you go online, you click one, you get a static image. And that's sometimes useful. In this kind of field, where you're actually looking at the relationship between a protein structure and its function, and it's true, I'm sure you can relate to this in your own disciplines, that is one singular view of a whole process, a whole set of things that one would want to visualize. So why is it just one silly static image? So the idea, of course, is that behind that image, which is like a cue to get you started, there's a whole mass of metadata that actually includes web service calls which actually go out somewhere seamlessly, pull the data that's associated with that image and display it in a form across here in a way that I can then render it and interact with it. And when I interact with it, I can then annotate it, and I can actually share those annotations and do the kinds of things we're so used to doing in other forums. But right now, it's still pretty hard to do that with the majority of the scientific literature. I actually inquire based on that image. As I mouse over parts of that image, I'm pulling knowledge from other places. Could be databases, could be other journal articles. And then at some point, I'm particularly interested in one facet of this picture. There's a glycine-rich loop, which is important for drug binding, for example. I then get a composite view from multiple sources, a mashup of information about that particular feature, which then drives me around this cycle again. So it's basically the knowledge data cycle with different views on it, and that I can tailor for my own particular interests. So this is sort of the basic idea. Do we have it? Well, not really. But so what's stopping us? I think right now probably the biggest bottleneck, in my view, is governance. Is that basically the databases and the journals, which are the traditional holders of data versus knowledge, don't interoperate very well at all. They don't even talk to each other. There's slight signs on the horizon, like the signaling gateways that Nature Publishing Group have as one example. And certainly there's a movement slightly in this direction, but it's a question of time and speed, and I don't think it's there. There's also this big issue of reward. What's the reward for doing all this? And we'll come back to that. And then there's metadata standards and things that you know very, very well. And then, in some ways, there aren't really exemplars that, I can point to this and say, this looks good, but does it exist? No. But some parts of it exist. And I think it would be very useful to have, an exemplar. Now, it's just, to me, absolutely insane that it doesn't exist, because we have so much knowledge and data. Just in the biosciences, in my area, 1.2 million papers or thereabouts are being indexed by PubMed every year. By the time a student comes into my office with their very first draft of the very first paper that they're so proud of, by the time we sit and talked about it for 30 minutes, X number of papers have been published. 20, 50, I never tell the student that because it's a little disheartening, but that's the name of the game. And on the other hand, we have databases of which this is a year old now, there's well over 1,000. And it's the way we do this, again, strikes me as completely nuts. I can go to NIH, NSF, and I can write a grant to build one of these, add to this, to make it 1,079. I get some money, I'm very happy. 3 years later, I come to actually get a renewal on that, no way. I have just got to the point where the community is interested and people are starting to use it, and I wouldn't say it necessarily goes into maintenance mode, but it goes partially into maintenance mode, and then it's very hard to fund it. And so, when you look at this nucleic acids research issue, and you start looking at how many of those 1,000 resources exist after 1 year, 2 years, 3 years, you're losing like 10% per year. So, is that the best use of resources? Probably not. And then you've got other aspects of craziness that, on one hand, you've got on the left hand side, you've got some measure of persistence, and you've got, to some degree, a common interface. On the right-hand side, you've got lack of persistence and certainly not a common interface. So, I think both of these environments can learn from each other. And so we've actually been trying, I want to give you an example of where we've been trying to do this and how what it actually provides. I wouldn't by any means call it an exemplar, but it is, I believe, and you can argue with me, I enjoy that, a step in the right direction. So just by way of background, the example I'm going to give you, again, uses this protein data bank, which is one of the oldest databases in biology. And you can see it's got this typical growth curve for this kind of data. It also represents, these are all molecules to size, so essentially it emphasizes that the data has got a lot more complex over time. And so it's very similar to the kinds of data sets that many of you have. I think where it differs, it's almost a perfect example to be working with, because there's a very contained set of data that which actually, by the way, has a DOI assigned to it, which actually also has associated with it, in many cases, a publication. So there's this pretty good this correspondence, and the data itself, by many data standards, is pretty well structured and all the rest of it. So this represents, in some ways, a very almost best-case scenario. So what can you do with this? So here's an example of a view from the database, okay? I mean, it's not going to mean anything to you, but let me just explain it, and hopefully you'll get the idea. So essentially, here's a piece of data. Now, what we've done is we've gone and then, by actually scanning all of PubMed Central, which is the open access literature in this field, we've actually pulled out all references to that data set, okay? Done by either the DOI, which frankly hardly anyone uses in a paper still, but also the identifier that's fairly unique. So this is really simple stuff, okay? But what it does, and then we do that contextually. So just by virtue of the first couple of figures of that paper, it tells someone a lot. Ironically, authors, the depositors of this data, really like this, because quite often the use of their data is not cited. So if they go to the web of knowledge, they're not going to find this reference. Suddenly they discover how people have been using their data for the very first time in the literature. I mean, this is just, relatively trivial examples. But what also comes out of this is a gain of knowledge. Because what we also see is we then, and this is in the bottom half, but just to explain it, is we actually make associations between this one piece of data, this one structure, and any other structures that were referenced in the literature, either in the same paper or in other papers. And that has a very powerful possibility, because you're not actually reading anything anymore. You're just making association between data sets by virtue of the fact they were mentioned in the same literature. This is very simple stuff, but actually turns out to be quite powerful. And I'll show you an example of where that's coming to be. So that was sort of looking at it from the data side. We also developed, and I think there are definitely better instances of this out there now, on the knowledge side, the so-called PubMed Central, the literature, the open access literature, we indexed all of that and built our own resource, which we update every week. Now, I don't think it's as powerful as things like Reflect and some of the other systems that are out there, but where we actually, and I have no intent really of supporting it as a web resource. Where it's proving to be very useful is more and more biological data resources are using its API to actually, through web services, to get at the kind of information I just talked about. Forget about structures. You do it for genes. You do it for any referenceable material in that literature. And so it enables other databases to actually make these kinds of correspondences. So it's, in a sense, it's a no-brainer. What you get from the knowledge side, the so-called journal paper side, is this kind of thing. So basically, you can be reading the paper, and this is trivial. You mouse over, and suddenly you without even knowing, you make a web service call, and you pull data from various resources, and you basically, in the context of what you're reading, you get information out of the databases, which is valuable. It's more than just a figure now. It's basically, a whole interactive environment that you've pulled from a database as you read the paper, without even leaving the paper. So, not particularly earth-shattering, but from a practicing scientist point of view, seems to be pretty useful. So that brings into the whole notion of doing this and having these small bits of JavaScript, these widgets, which people embed all over the place. So I wrote an editorial, I don't know, when was it? Doesn't even say, last year I think. No, it was this year, sorry. Will widgets and semantic tagging change computational biology? I believe it will. Clearly I was the only one. Hardly anyone responded to it. You can have the commentary feature in PLOS, so people can respond to articles. And only the few people who did respond agree with me, so what use is that? But I think it strikes me as a very powerful mechanism. So here's just examples. Here I can embed this widget in any page I want, and I can actually do a calculation on the remote database resource. In this case, it would actually be comparing two three-dimensional structures. It doesn't matter what it is, but it's there. I've actually taken that capability and I've spread it all over the web. And the thing is, even I can do it. It's actually very easy to do. So I think these kinds of notions. So here's just embedding different kinds of things, images and so forth. Of course, you don't no longer have to keep things up to date in your own resource because you're actually pulling from the primary source each time. So that's useful. I don't expect you to read any of this, but it's the notion of doing the same thing in just semantic tagging. So you can have any kind of text. Here's just an example, and it refers to a person. And one of the supported widgets is essentially to immediately go and search this resource and a bunch of other resources for data that person has actually deposited in the database. So in other words, and that's just one trivial example. You can actually semantically tag, and we provide a whole series of different tags to do different things that you can embed within your own content. So ideally, you'd like to see that publishers embrace this kind of thing. And I think it behoves the database people to actually make sure that they have the APIs and the capability to meet this need. And we see this kind of thing increasing. It's potentially, I'd say in 5 years, could be one of the major uses of the data resource, which right now is all about going to the web pages and querying and analyzing. And then, of course, you have these other features where, you actually, and I'd say this is by no means the best way to do this now, but it's semantically marking up the text of the papers themselves automatically. So in this case, it's, you're going out to the Obo Foundry, you're checking against ontological terms, and you're mapping those into the paper. You can look at them, you can see all references to it. Others are doing this now. It's potentially useful. And others being, here's now a recent development from Elsevier, for example. So these things, I think we've got a groundswell here. We've got the scientists pushing from the bottom up and making some of these things happen. So, but when you do this, if you post-process and add semantic enrichment to the literature, that's not ideal because it's not authoritative and it's not necessarily being done as the expert, namely the author, would want. So the idea, of course, is that you do it at the time you write the paper. And we developed a plugin for Word, thanks to Tony and Lee and others at Microsoft, to make this happen. And essentially, it's just conceptually, it's just like using the spell checker. As you type something, it will check against pseudonym tables and things to see whether you want to use a semantically correct term in terms of its ontological representation, or if you use a database term, whether in fact it pulls from the database to see if that was really what you meant. And so you can actually see these things as you author. Okay? As you do that, then you can either accept them, or you can actually, as part of the copy of record, if you like, or you can actually have them tagged in the background as metadata, and then you've got a semantic hook that you may not even actually see, but it's in the paper. Okay? Or you can, of course, just ignore it. So I think this all sounds good to me. I don't know what it sounds like to you, but it sounds good to me. But what's the incentive? Okay? I talked about this at January at a meeting, and the following speaker got up from the American Chemical Society and basically said, the day someone submits a paper with this semantic tagging, we'll figure out what to do with it. Well, it just struck me that was perhaps not the right attitude, to put it very politely. That they shouldn't be waiting for us, that the publishers should really be trying to embrace this and really making incentives to make it happen, because it really has the potential, and I mean there's a caveat here, we are not far along in this to really test how much additional comprehension we actually get out of it. But we need to get to that point and see. And I think the publishers, whoever they are, should really be trying to help us. So the idea, if someone did this, that, for example, what we all care about in this reward system that's totally screwy, which we'll get to in a minute, is the idea that there's some reward for doing this, fast-tracking the paper. And, of course, potentially, at least for a while, it could be a competitive advantage to the publisher if the customer, namely the scientist, actually thought it was worthwhile. So these are possible things you can do. But as I alluded to a minute ago, there's also the possibility of getting additional knowledge just by virtue of doing this kind of thing. So here's a simple network that you just generate automatically, and it doesn't matter what the nodes are specifically, but let's say they're genes, okay? So essentially, each one of those things is a gene. And an edge is drawn between two genes if they're referenced in the same paper. Do this automatically. Just scan the literature, check it out. Thickness of an edge is the number of times they appear. So immediately you see that this network has some topology. So what could that possibly mean? So then you start overlaying other characteristics of the literature onto the network. Something totally trivial. You know, what are the kind of journals where these things occur? Okay, this happens to occur in immunology. This happens to occur in literature that's associated with cardiac disease. So what's this particular node in the middle? Well, maybe it's something that has a shared function that people in the cardiac literature probably didn't realize that it had some immunological implications. So these are the kinds of things that just sort of fall out of this stuff automatically. It all requires open access and free access to the text, of course. So that's just a hypothetical example. So enough about the relationship between data and the knowledge associated with that data. I think we also need to think more about the tools that we use to visualize. Many of you in this room are involved in visualization. Now here's an example from my own sphere where, you know, these are fantastic tools. They've been around for a long time, and they basically represent molecules in different ways, okay? Molecular graphics is an old field. There's a resource here in San Francisco at UCSF that's the oldest NCRR resource, if you know what that is, and it's over 30 years old. So they've been around since the very beginning, the very first graphics cards. But I think there are problems with these, because what's happened is, and so these are what, as I see the problems, they're not as versatile as they should be in this day and age. They don't respond to the data they're reading. They only respond to one kind of data, and God forbid it's not in the right format. Okay, so there's that issue. The view that you get once you display that, it doesn't matter whether you're a high school student, a Nobel laureate, an immunologist, a medicinal chemist, you get the same view. You know, and then you have to start digging in. You have to know a lot to actually get the kind of view you want. It seems in this day and age, and you can't actually share those kinds of, whatever you finally come up with, however you finally annotate that thing, you can't really share. There are read-only tools. They don't actually write back annotation, which you can then share. So, I mean, in some sense it sounds trite, but that's essentially what everybody's done. So really what you want is and we've sort of played around in this space and offer, not an exemplar, but an example of thinking differently about these kinds of the way one visualizes. So in the end, you don't actually build an end tool. Because if you do that, someone comes to you and says, well, I wish it could do this, I wish it could do that. And you get feature creep. Before long, there's only a few people who can use the damn thing. So basically, you essentially build a framework from which others can actually build the applications. And you support read-write access. And essentially what you get are a bunch of, instead of one all-encompassing tool, you get a bunch of simple visualization tools that actually respond. They respond to the data they're reading. And they also respond to some kind of profile around the user to actually provide the kind of interface that's actually useful to an immunologist versus a medicinal chemist. So these sorts of approaches, at least to me, I'll be happy to argue about this, seem to be the way to think about this. So this is just another example of trying to accelerate the process of discovery. Now, I think probably the hardest thing in all of this is the reward system needs to change. I mean, we're in a serious situation with this. We have been for a long time. So what do we need to do to change the system so there is reward to start doing the kinds of things to accelerate discovery? No one's going to accelerate discovery unless they're rewarded for it. So I think, first of all, there's some prerequisites to it. And these prerequisites are we need to have proper author disambiguation. And we'll get, I think that's coming, and I think that's a sign that, all is not lost. We need better auditing, the whole identification of metrics of scholarship. I'll give you an example of at least why I'm thinking about this stuff. And as seniors, myself included, I was so frustrated by this. So those of you in universities, you probably sit on committees where you actually review files. I find it a really disheartening situation because, I'm perhaps the only computational biologist sitting on one of these things. They're all experimentalists, and a file comes in, and bottom line is the people who are making the decisions really are not qualified really to evaluate that person's work. And so, I'm everlastingly saying, I think we ought to pay attention to the fact that, writing a piece of software that many people use is an amazing contribution. And, many people don't appreciate that. I don't mean to sort of make this computational experimental divide because things are a lot better than they used to be. But notwithstanding, I think we as senior people have a responsibility to actually educate committees and educate the younger people to actually make a good case for themselves. And I just wrote about this, so that when you actually prepare your file, you should really emphasize quantitatively what you're bringing to the table, which is more than just a couple of publications in leading-edge journals, which is the most stupid way of measuring anyone. For a society, for a group of people as we are, who are so quantitative, how could we possibly use the impact factor of a journal to measure anyone's, abilities? It's just crazy. Sorry, going off on a bit of a tangent. Coming back. So, a way of doing this, of course, is to actually provide committees with and for yourself, for that matter, with the right tools. And there's a whole bunch of tools out there now. We actually saw an example from Adam last night. Here's just a couple of others. So the network on the left is actually my collaboration network. So it basically shows all the people I've collaborated, how they've collaborated with each other. We actually use this not so much, well, we use it partly in promotion now, but we also we actually use it when we're hiring people. If we want to see how collaborative someone is, this is an immediate way of doing that. And in the biosciences, the way it's working is it's just going to PubMed, it's pulling all of that person's papers and all the authors that they've ever published with and building a network. It's done by Mark Gerstein's lab. And there are tools now that exist in other places, like in Researcher ID from Thomson Reuters. So you can do a variety of graphics things. You can see where people are collaborating around the world with biomed experts and these kinds of things. So these are useful tools. But again, there's some other aspect of this which is also crazy. Everyone in this room has reformulated their CV, God knows how many times, for so many different purposes. Why don't we have one central academic profile, or whatever profile we want it to be, that we can build all these things from? We can actually immediately get all of these tools. So maybe this will coalesce. Maybe each of these different organizations will ultimately, and we'll have something that's much more standardized. It would be very useful. And of course, what we're not doing is we're not taking into account the alternative forms of scholarship, which, I think is just egregious. Okay, so here's the typical cycle that we all know so well. So what are the alternative forms of scholarship? Well, I'm an editor-in-chief of a journal. I see lots of reviews. My God, there's some bad reviews. But there's also some excellent ones that actually really improve the scientific paper. And that person who actually made that review currently gets, put it politely, bugger all reward for doing it. Okay? We've now started to look at metrics for how we actually can provide ratings of reviews. We're talking about this in PLOS. And then how that can be passed on, in principle, to anyone, but certainly back to the reviewer themselves. There's you don't get any feedback about how good your reviews are. Blogging, of course, is another whole amazing enterprise that really is unrewarded at this point. If I tie that back to papers and reviews, I have occasionally seen a blog on a paper that's better than the review that actually was part of that paper when it was accepted. Where's the reward for that? And then, of course, data and the whole aspect of curation. You know how much taxpayer money is currently going into getting people to read the literature and take information out of that and put it back into databases? It just seems a bit silly to me. But those people deserve to be recognized. And that's not a good way of recognizing that either. So what do we do about that? First of all, we have to solve the author disambiguation problem. So Tony alluded to this last night, down the line in a second. So here's an example, okay, just from my own personal experience. Does anybody remember this book? A couple of people. So I wrote this book in 1990, and I have to say it was one of those things that was totally fortuitous because no one wanted to publish it. I finally got, actually it was Digital Press that was taken over by Prentice Hall, to publish it. And then essentially, almost the time it came out, the RISC chip appeared. So suddenly there was this mass migration away from the VMS operating system to Unix. So everybody thought I was some kind of oracle. I could foresee the future. It was purely by accident. I mean, but anyway, that's another story. But I started going to USIG or whatever it was Usenix and all these kinds of meetings. And people kept asking me, did I write the Bourne shell? And I said no. That was, if I had $1 for everyone who asked me, I wouldn't be standing here, believe me. But basically, there was no, that could have been disambiguated. I'm Philip Bourne, he's Steve Bourne. But there's more subtle examples. And here's an example of a paper, and okay, I'm middle initial, but you know the whole thing. Disambiguation is a big issue. So I want the Bourne identity, and since and this is controversial. I mean, I wrote an editorial a while back called "I'm not a scientist, I'm a number," and that got a lot of pushback and a lot of threats. But the fact is that it is a DOI for people, and whether we like it or not, it seems to be coming. And I mean, now, when I first started talking about this, it was just a sea of different numbers out there. It does appear to me, and people in the audience can correct me, that we are coalescing around ORCID. And I think that is actually a very important development. And because when we have that, we can then tag unambiguously every single piece of scholarly output that we produce. And in preparation for that, even in this article, came up with a scholar factor, which of course was supposed to be totally ridiculous, but some people took it seriously. But the basic idea is, everybody's fixated on the H factor, so take that H factor, and then add all these other things that are important scholarly output, weight them in some way, and come up with a new factor. And we're beginning to get the metrics to do that. So in the end, what I would like to be able to do is to essentially press a button and get the right person, and essentially get a full breakdown of that person's scholarly output. So if I want to know what blog posts have been linked, have some weight to them, that I don't necessarily, maybe they've made 500 blog posts. But what I want to know is, what are the ratings of those? How many times have they been linked to? And there are ways of doing all of this. It's just none of us have actually sort of sat down and put it all together. So I think these are sorts of things that really need to be done. So that was the reward systems. So I'm going on now to a different, so these are all things I think we should be considering in this acceleration of discovery. Fix the reward system. Okay, we've done that now, well done. Now let's move on to scientific management tools. Okay, so here's the truth of my laboratory, all right? My laboratory is basically a total hub and spoke thing. It's not that the people in the lab don't talk to each other. They do, and they do a great job. They do some wonderful work. But there's too much of it, actually, of the intellectual knowledge of that lab is sitting into my ever-increasing number of email folders in this hub and spoke kind of mentality. Things come through me and go out. And there's not the optimal sharing of information, and that's just in our own lab, let alone with anyone else. So this is a problem. And then there are all these stories that we all have about how we lose data. When the postdoc or graduate student leaves, so does the data and everything else. So there's all these things, and then there's all the stuff. Making a presentation. I don't have the tools I really need to actually immediately make the kind of presentation. I should also almost be able to make this presentation I'm giving to you today automatically just by metadata and other aspects of things that are tagged to my individual slides, or metadata that's automatically deciphered and actually offers me different presentations around that material accordance to agreement with different terms. I'm making all this up. You get the idea. So this goes on and on. And there are some fantastic tools, okay? You know, including those that are made by people sitting here in the front row, as well as all over. So, you know, we use these tools, but there's some issues with it, you know, because, and you know what they are. I think we're all confused. The long tail, maybe those right on the cusp and right in the core of cyber infrastructure, whatever it might be, might not be confused. But if I walk around my department and I talk to my faculty, you know, most of them have never heard of Basecamp or SharePoint or any of these things. And even if they had, they wouldn't know where to begin. So there's that issue. So I think there's also, you know, we're not going to get a grand unified thing here, but the interoperability between the things that come out should be there more than it is today, in my opinion. And then, you know, I think the reward is still removed from the use of the tools. It's very indirect. If you happen to persevere with a set of tools, let's just pick on my experiment, if you persevere with that, there's absolutely a reward. But it's subtle and not necessarily direct, in the sense that, you know, ultimately you're more productive, and that is a reward in itself. But the idea of actually having something that was much more connected to the publication, the reward process itself, namely the publication process. So the idea of publishing those workflows and annotating those workflows into a form, you know, is one example. I mean, you could argue that with some of the other tools that were on the previous slide as well. So, you know, I think that's, you know, we need to do better with the management tools. And then I think what's also ironic, and it's all around us every day, but doesn't seem to, at least to my way of thinking, to be there in science, is we need to unleash the full power of the internet in the scientific endeavour. Maybe it sounds stupid, but I don't think, for the most part, that we're really doing that. And I'll just give you an example from my own lab where this sort of hit me and where it led. So one day I walked into the lab, it's about 3 or 4 years ago now, and there were 4 of my graduate students, headsets on, all looking diligently at the screen. I think, good research is going on here, I should move away, because if I stay here, I'll ruin it all. But in actual fact, when I looked more closely, of course, they were all watching YouTube. And that's the surprise when I caught them. But, you know, and then what I did, this is some time ago, is I thought, you know, YouTube could really increase our rate of discovery. And I actually went and looked at YouTube, and the first thing you do, of course, is I typed in my own name. And what came up on the screen was the little video clip I'd made for UCSD, and immediately under it there were 4 nude guys standing there, which has got nothing to do with the title of my talk. But I thought, what on earth is this? And it just turned out that one of them name was Phil Bourne, and he was an Austrian nude dancer. Well, all that's very nice, but I didn't necessarily want my science associated with that. And so we decided to go off and do something of our own. And in fact, what's happened in the meantime is I think YouTube and whatever the video form has become a very powerful way of telling scientific stories. It doesn't necessarily matter where it is. I mean, what we've done is try to do something a little different to actually improve that comprehension. And I'll give you an example of that. So I made everyone in my lab, when they had a paper come out, I made them make what we call a pubcast. Now, a pubcast is a synchronized video presentation that's synchronized with the paper. So we have a website where you can go to and you can do all this. All right? It's all done on. So you make a video and then you upload it. You pull the paper from PubMed Central or wherever it might come from, and then you just, as you play the video, you drag across bits of the paper, and so it appears together. And so what you've created is, if you think about this 1.2 million papers that we never have time to read, what we're doing here is we've gone from an abstract, which is like 1 minute that gives you some decision about whether you're interested in the paper, to the 2 or 3 hours it takes to actually understand it fully. Well, what we're doing here is trying to get the author to give you a 5 to 10 minute succinct representation of that paper. So you could be reading that paper. You don't even have to use the video. You could just read the paper, and suddenly you read something. What is she or he saying about that? And then you click on that particular part of the paper, and up pops the author. Hello, let me tell you about this PCR experiment I did. But it's synchronized with that part of the paper. And so, it's an experiment. Has it worked? Well, I'll tell you about that in a sec. But what's happened is, yes, it's worked, but in ways that I didn't think. So, first of all, when the students did this, they enjoyed the experiment. What I actually found is this kid here, Chris DuPont, he's just a really smart guy, but he's very shy. And whenever I used to talk to him, he would talk to me. I thought, he's going to be completely hopeless at this. And when we got him in front of the camera, he was just completely opposite. He was like the most out there person you could possibly imagine. Go figure. And one of my graduate students were all going to become a set of SciveeCasters. Well, the fact is that I'm standing here, and part of the reason I'm standing here is because you get used to giving talks, and you try and you think you do a reasonable job. So you're already doing that, it's just a different medium. The idea was they liked it because rather than the PI, it was they who were actually out there, and they were being exposed. When I was a graduate student, and my first paper, God knows how many years ago, if I was told that one day I'll have a worldwide audience of people who could view that paper any time, day or night, I think they were crazy. Now that's there, and it's wonderful. So what went wrong? Just say that, I won't say what went wrong, but this is sort of where we are. So this is kind of, I won't go into the details of all this, but I think there's a very important element which I alluded to before, is that what's happened with this is it moved from essentially a seed NSF grant into an attempt to be sustainable as a business. And I think, we have to face the facts that if you look at all the data that's out there now, all the data that's coming, this sustainability is absolutely critical. I already alluded to the fact that, all these resources are created and die on the vine. So, so that we really have to address. And this is sort of an effort. So the idea is to actually keep all this content free and open and all the rest of it, but at the same time have a model that enables it to actually sustain itself. And I won't go into the details of that, but I'm happy to talk to anyone about it. So what emerged from all of this was, first of all, the idea of having a paper. My idea was that a student would flip open the laptop, turn on the webcam, start talking enthusiastically, and everything would be honky-dory. But no, the PI gets involved. And when the PI gets involved, forget about it. It becomes a Cecil B. DeMille's epic. It never gets finished. It costs too much, and it bombs at the box office. So so that kind of didn't work so well. What did work much better was postercasts. Same idea, but basically, you synchronize with someone making a poster presentation. The nice thing about that is that it's in essence what the students do anyway, and they really, you can recreate that same feel as listening to someone talk about their poster, and it's persistent. Poster's up there for several hours, like today, and then it disappears and it goes on the lab wall, and only a few people will see it. Here, if you wish, it can be there as long as you want. So this is just that sort of idea. So Tony's giving me the finger or something. I don't. So the piece of paper. Sorry. So let me just sort of summarize what I've tried to say, even when my title was a bit off. So by life, I'm talking about things that I'm sort of experiencing in the life sciences, and I'm actually seeing and trying, I guess, in a small way to contribute to. And I think reaming is the idea of making it accurate and smooth and seamless and faster delivery. And the idea of the play on the meaning of life was to actually sort of say that there was a conversation cards. So the rest was just, I think, a few examples of some very big problems which you are all already contributing to solving, and I applaud you for it, and thank you for having me here. Thank you.
Thanks very much, Phil. We're started a little late, so I think we can have a few questions, as I'm sure there will be some.
I can't remember what it stands for. Someone help me out here. But basically, it's now a group of organisations, including some major publishers, who've got behind the idea of essentially creating this, and Crossref's involved as well, to create essentially the equivalent for a DOI for people. So instead of assigning a unique resolvable reference to a scientific paper, it's actually a resolvable reference to a human being. Now, I think, just to sort of say that, I think it's very important as database providers and publishers that we get behind this. And essentially, if you have any kind of Web 2.0 resource where people actually have to log into, the idea is, is to really insist that people use this.